So, consider in triangle ADC, side DC is opposite to sine, therefore, DC by sin theta is equals to 180 minus phi, the side which is opposite to that is AC, AC by sin 180 minus phi. We all know sin 180 minus theta or sin 180 minus phi is same as sin phi, therefore, sin theta by sin phi is equals to DC by AC. From equation number 1, equation number 2, I can say BD by AB is equals to DC by AC. From this I can say BD is to DC is equals to AB is to AC. This is very important property of a angular bisector. So, here an angular bisector of a triangle. So, for this triangular angular bisector AD divides the opposite side BC. Angular bisector of a triangle AD divides the opposite sides BC in the ratio of its adjacent sides. Now, what are its adjacent sides? The adjacent sides are AB and AC. So, if you want BD in this, it divides BD in the ratio of C is to B. It divides BC in the ratio of C is to B. I would say C out of B plus C into side A. If you want DC, which is equals to B out of B plus C into that side A. Now, here in this triangle, I am taking two internal angular bisectors. Let the triangle be ABC. Here BD and CD are the angular bisector of triangle ABC. Let this be, let angle B is equals to 2x, angle C is equals to 2y. So, it bisects the angle, therefore, x, x. It bisects the angle, therefore, y and y. If it is theta, here our aim is to find out this angle theta. First, in triangle ABC, two x plus 2y plus angle A is equals to 180. X plus y is equals to, divide everything by 2, it becomes 90 minus angle A by 2. This angle A, sometimes you also refer to it as angle BAC by 2. Remember it as an equation 1. It is very important in upcoming derivations. Remember that x plus y is equals to 90 minus angle A by 2 or else angle BAC by 2. Both of them are same here. Now, consider triangle BDC. In BDC, x plus y plus theta is equals to 180. Theta is equals to 180 minus x plus y. If you substitute x plus y here, 180 minus 90 becomes 90 degrees. Minus of minus becomes plus, therefore, plus angle A by 2. So, remember this theta, the angle formed at the two internal bisectors of a triangle is 90 plus the third angle by 2. So, here I am taking two internal bisectors. These are internal bisectors. Now I'll take two external bisectors. Here I am taking two external bisectors. These are external bisectors, external angular bisectors. We have already considered the angle B as 2x, angle C becomes 2y. Remaining angle here is 180 minus 2x. If you divide 180 minus 2x by 2, this whole entire angle is 180 minus 2x, remaining angle outside. If you divide it by 2, it becomes 90 minus x. Therefore, this angle is 90 minus x. We know vertically opposite angles are equal. Therefore, this becomes 90 minus x. This becomes 90 minus y. This is angle A. We just need to find out angle BDC. Two external angular bisectors meet. Let this be theta again. So, in this triangle 90 minus x plus 90 minus y plus theta is equals to 180. 180 cancel, theta is equals to, you get x plus y. We know x plus y is equals to 90 minus angle A by 2. So, angle formed when two external angular bisectors meet is 90 minus A by 2. We have seen when two internal bisectors meet, it is 90 plus A by 2. Now, we will take one internal bisector and one external bisector. So, here in this figure, you see one internal bisector and one external bisector. This one is an internal bisector, internal angular bisector. This is an external angular bisector. Let us take it as triangle ABC. This is D. Again, I am considering it as theta. This angle becomes x because it is 2x. Here it is 2y. This is 90 minus y. Because if you look at the external, the entire external angle becomes 180 minus 2y. You just divide it by 2, it becomes 90 minus y. Now, consider in triangle again BDC. X plus 2y plus 90 minus y plus theta is equals to 180. X plus y, you got it. X plus y is nothing but 90 minus A by 2 plus 90 plus theta is equals to 180. 180 gets cancelled. Theta here is equals to angle A by 2. So, when one internal angular bisector and one external angular bisectors meet, the angle formed here is the opposite, is nothing but third angle by 2. The angle formed by internal angular bisector, external angular bisector is third angle by 2. Let us look at all the three in a single figure. In this figure, ABC is the triangle. Two internal angular bisectors meet, it is an in center, I am taking it as I. This is I dash where two external angular bisectors meet. I double dash is one internal and one external angular bisector meet. This is internal angular bisector. This one is external angular bisector. We know BIC 90 plus angle A by 2. BI dash C 90 minus angle A by 2. BI double dash C is simply angle A by 2. So here these three are very important when it comes to angular bisector. Now we'll look at some problems based on angular bisector. Let's look at the first problem based on this angular bisector. The external angular bisectors of angle B and angle C of triangle ABC meet at the point P. In the explanation I said it is D, but here it is given as angle P, point P. If BAC is nothing but angle A is 80, then BPC. Without figure we can say angle BPC is equals to two external angular bisectors, therefore 90 minus angle BAC by 2. So here angle BAC is 80 divided by 2. So 90 minus 40 is 50 degrees. Let's look at the next question. The external bisectors of angle B and angle C of triangle ABC, where AB and AC extended to E and F respectively meet at point P. If BAC is equals to 100, then the measure of BPC, it is same as the previous one. We know when two external angular bisectors meet, angle BPC is equals to 90 minus angle A by 2 or else angle BAC by 2. So here it is 90 minus 100 by 2 is 50, 90 minus 50 is equals to 40. So here this question is also based on external bisector. Look at the next question here. ABC is the triangle. The bisectors of the internal angle B and the external angle C intersect at D. In this triangle, one is internal angular bisector and the other one is an external angular bisector. And BDC is given is 50 degrees, then angle A. So you can consider this figure. You are already familiar with this. If this angle is given as 50, BDC, one is internal, one external, then what is A? We know angle BDC is equals to angle A by 2. Therefore, angle A is equals to 2 times of angle BDC, which is 2 times of 50, 100 degrees. Look at this one. If the triangle ABC, the bisectors of angle B and C intersect at O, the bisectors, which means if nothing is mentioned, you take the internal bisectors of B and C meet at O, which of the following statements is correct? Look at the statements here. Angle BOC is equals to 90. We know when two internal angular bisectors meet, the angle BOC is equals to 90 plus A by 2. We take it as 90 plus A by 2 is the answer, because these are two internal angular bisectors. Look at the next question now. Here in this triangle ABC, in center is O. In center, we know in center is a line which is intersection of angular bisectors, and angle BOC is equals to 110, then the measure of BAC. We know BOC, two internal angular bisectors, then we can say 90 plus angle A by 2. If it is 110 is equals to 90 plus angle A by 2. Angle A by 2 is 20, therefore angle A is equals to 40 degrees. Look at the next question. O is the incenter of triangle ABC and angle A is equals to 30, then BOC. Incenter means it is an intersection point of angular bisector. Therefore, we know direct formula BOC is equals to 90 plus A by 2. So 90 plus 30 by 2 is 15. So it's 105 degrees here. If the incenter of triangle ABC is equals to triangle ABC and A is equals to 60, then the value of BIC. Here BIC is clearly is the angle formed by two internal bisectors. We know it as 90 plus A by 2. So A is 60 degrees, 90 plus 60 by 2, we take 90 plus 60 by 2. It's 90 plus 30, which is 120 degrees. Look at here. If I is the incenter of triangle ABC and BIC is 135 degrees, then BABC, triangle ABC is what kind of triangle he is asking you. In order to say the triangle ABC is which kind of triangle, you need to find out angle A here. Now BIC is an angle formed by two internal bisectors. So we know angle BIC is equals to 90 plus A by 2. So 90 plus A by 2, or else A by 2 plus 90 is equals to 135. Angle A is equals to 2 times of 45. So angle A is equals to 90 degrees. So if angle A is equals to 90 degrees, we call A is a right angle triangle. Suppose if angle A is greater than 90, then we say triangle is a acute angle triangle. So we can't say anything about equilateral and obtuse by using this property. Now look at the next one. I is the incenter of a triangle ABC if triangle ABC is equals to 65 and triangle ACB is equals to 55 degrees. Angle ABC is equals to 65 degrees and angle ACB is equals to 55, the value of BIC. So here angle ABC is nothing but angle B. Angle B is given as 65 degrees. Angle C is given as 55 degrees. Therefore angle A is nothing but, this is 120, 180 minus 120 is equals to 60 degrees. Angle BIC is equals to 90 plus angle A by 2, which is 90 plus 30, 120 degrees. Look at the next question. In triangle PQR, the internal bisector of Q and R meets at O. If angle QPR is equals to 70, then what is the value of OQR? QOR. QOR is equals to, we know two internal angular bisectors meet, 90 plus angle P. Angle P, instead of P we are taking QPR by 2. So it's 90 plus 70 by 2 is 35. 90 plus 35 is 125 degrees. So major question which involves internal bisectors are based on angles. Either they may ask you two internal bisectors, or else they may ask you two external bisectors, or else they may ask you one internal bisector and one external bisector. Just see the formula so that you can directly put the values in it. All you have to understand the question and where you have to put the value. So that's all, it makes it your answer in just 10 to 20 seconds. All you have to do in this internal bisector and incenter thing is, you have to remember what happens when two internal angular bisectors meet and what happens when two external angular bisectors meet and one internal and one external angular bisectors meet. So all you have to remember the direct formulas and read the question carefully and put the value wherever it belongs. So it will give you your answer just in 10 to 20 seconds if you are aware of all these formulas. Thank you. Hello viewers, today we are going to look at triangles and its various kinds of centers. Mostly we will focus on the centers of triangles. We will see the different centers we have here. First, you all see 4 triangles. Almost all are similar until unless I differentiate them. Triangle ABC, here in the first figure AD, I'm saying AD is a median. So AD is a median here. Median is a line which bisects the opposite side, and median also divides the entire triangle into two equal areas. And if you look at the median, median divides the entire triangle into two equal areas, and the intersection point of medians, I call it as IP, that is intersection point. Intersection point of a medians is centroid. Now look at the second figure. Here AD, I call it as an angular bisector. In the second figure, AD is an angular bisector. The first figure, AD is median which divides the opposite side. Here it divides the angle. So these two angles are same, theta and theta. Here this is phi, this is phi. Intersection point of angular bisectors is in center. Now look at the third figure. Here AD is perpendicular to the base BC. BE is also perpendicular to AC. So you call it as an altitude. And the intersection point of altitudes is called orthocenter. In the last one, I don't call it as AD, but here this line is perpendicular to BC and it is dividing BC into two equal parts. So I call it perpendicular bisector. So here this is perpendicular bisector, and the intersection of perpendicular bisectors is called a circumcenter. First, medians, intersection. What is median? A line which divides the opposite side into two equal parts is a median. Now intersection point of medians is called centroid. Second one, the line which divides the angle into two equal angles is angular bisector, which is dividing the angle into two equal angles. Here AD is an angular bisector of angle A and BE is an angular bisector of angle B. Now the intersection point of two angular bisector, we call it as in center. And look at the third figure. The third one is perpendicular. AD is perpendicular to the base BC. So intersection point of these altitudes, we call it as an altitude. Intersection point of altitudes is orthocenter. Now in the fourth figure, here this line is perpendicular to the base BC and it is dividing the BC into two equal parts. We call it as a perpendicular bisector. Intersection point of perpendicular bisectors is circumcenter. First we look at how centroid appears in the different triangles. Suppose if I take an acute angle triangle, that point here is a centroid. In an acute angle triangle, centroid always stays inside. Even if you take it as an obtuse angle triangle, this is an obtuse angle triangle, it is also inside. If you take exactly a right angle triangle, in right angle triangle also centroid is always inside. So centroid for acute angle triangle and obtuse angle triangle and right angle triangle, it always inside. Now here these are three angular bisectors. Look at it, is called in center. The intersection point is in center. In center is always equidistant. In center is always equidistant from the sides. And here for an acute angle triangle or obtuse angle, this is an obtuse angle triangle. In center stays inside. This is a right angle triangle. In center stays inside. Even if you take an acute angle triangle, all angles are acute angles. Here also it stays inside. So for all triangles it stays inside because it's an in center, and in center is equidistant from all its sides, not from vertices. It is equidistant from all its sides because you draw a circle inside. Now we look at orthocenters. Orthocenter is actually intersection point of perpendicular, as you see in the figure. Look at the perpendiculars here. If it is an obtuse angle triangle, orthocenter stays outside. If it is an acute angle triangle, it is coming inside. If I take exactly a right angle triangle, orthocenter is exactly at right vertex. If I take right angle at A, orthocenter stays at A. If I take the right angle at C, so orthocenter for right angle triangles is at right vertex. For an acute angle triangle, it stays inside. For obtuse angle triangle, it goes outside. So acute, obtuse, for a right angle triangle, it is exactly at the right vertex. So even if I take the right vertex at B, orthocenter stays at right vertex. Acute inside. If I go for obtuse, it goes outside. Now we will look at circumcenter. Circumcenter is an intersection point of perpendicular bisectors. For an acute angle triangle, it stays outside, as you see. For a right angle triangle, right vertex at A, but for a right angle triangle, it is exactly the midpoint of hypotenuse. It is exactly the midpoint of hypotenuse. For obtuse, outside. Acute, midpoint of hypotenuse. If you go for acute, it is inside. Acute inside, obtuse outside. For a right angle triangle, it is exactly at the midpoint of hypotenuse. And if you look at this circumcenter is always equidistant from the vertices. Circumcenter is always equidistant from vertices. If I take right angle at C, suppose, it is exactly midpoint of AB, acute, obtuse. We will see all the three positions once again: acute, for obtuse, and for right angle triangle. First, go with centroid, in center, orthocenter, circumcenter. Acute, all the centers are inside. Obtuse, acute is always inside. Obtuse, centroid and in-center is always inside. Inside, inside. For centroid is always inside, whatever the kind of triangle it is inside. But when it comes to obtuse and orthocenter will be outside. Circumcenter is also outside. When it comes to right angle triangle, orthocenter is at right vertex. At right vertex. Now circumcenter is exactly midpoint of hypotenuse. So these are the positions of centroid, in-center, orthocenter, circumcenter with respect to acute, obtuse and right angle triangles. Medians, centroid. Take a triangle, draw the median A, B, C. D is a median. D is a midpoint of BC. Now here AD is a median of this triangle. AD, as we know, divides the triangle into two equal areas and as well as BC into two equal parts. If I take BE is also median, centroid, and this O, centroid divides median in the ratio of two is to 1. This is 2 is to 1. So, centroid divides the median in the ratio 2 is to 1. We further look into it. I am taking all three medians here. Usually, if you take a triangle, its bases are in the ratio 2 is to 3. You look at two shaded regions here, one is the ash color one and one is the pink color one. If I ask you ratio of their areas for both the triangles, let me name it triangle ABCD. Here triangle ABD I am taking it, I am dividing triangle ABD by using AC into two parts. Into two triangles, the first one is ABC and the second one is ACD. If you ask me the ratio of ABC and ACD, they are in the ratio 3 is 2 is to 3. Their area is also in the ratio 2 is to 3. Because for both the triangle ABC and ACD, for ABC and ACD heights are same. So, areas will be in the ratio of their bases. So, remember this, when both the triangles having the same height, areas will be in the ratio of their bases. Look at triangle ABC. All this AD, BE and CF are medians. G is a centroid. Centroid divides the entire triangle. Centroid divides the median in the ratio 2 is to 1 and median divides the triangle into two halves. So, first one, I am just shading this region. Look at triangle ADC. Look at the triangle ADC. Triangle ADC is exactly half of ABC. Triangle ADC is half of area of triangle ABC. And you also look at only the pink part. And the hash color part. We know that the centroid divides the median in the ratio 2 is to 1. Therefore, this area is one part. Therefore, this entire hash color 1 is two parts. Therefore, I am taking it as 2x. This hash color area is 2x. Specifically naming it AGC is 2x. But look at what is GE. GE is a median for the triangle AGC. GE divides the triangle AGC into two equal parts, which means it is x. That 2x is divided into x and x. So, what do you get from this? All the 6, suppose all the 6 triangles you see here will have equal areas, whereas AD, BE and CF are medians. So, these 3 medians divide the triangle into 6 parts. All these 6 parts are having equal areas. Now, see here, I will take the triangle BGC. Area of triangle BGC is 1/3 of area of triangle ABC. Now take the triangle AFE. Now here E and F are midpoints, therefore triangle AFE this is a midpoint. According to midpoint theorem, we know it is line joining two midpoints is half of the third one. Therefore, sides ratio is 1:2. Areas ratio will be, if it is 1, the entire triangle becomes 4. So, we know if sides ratio is 1, because they become similar triangles, if sides ratio is 1:2, then areas ratio will be 1:4. Therefore, triangle AFE is 1/4 of the total triangle ABC. Area of triangle AFE is equals to 1/4 of area of triangle ABC. If you consider any small triangle in this, any small triangle, if you consider triangle CGD or DGC, it is 1/6 of the triangle ABC. Now again you consider, if you take ABC, here EF I am drawing separately. We know this EF and BC 1:2, their areas will be in the ratio 1:4. This triangle is 1/3. If 4 parts is 1/3 of a triangle, therefore this one part becomes 1/12 of the triangle. One part becomes 1/12 of a triangle. Therefore, this area becomes area of EFG becomes 1/12 of area of ABC. So, area of EFG becomes 1/12 of ABC. Consider the triangle ABC, and I am drawing all the medians here. Let this point be H. We know G is a centroid and H is a point which intersect AD and EF. We know AG is to GD is equals to 2:1, and we also know AH is to HD is equals to 1:1. Because it is line joining the midpoints, it is in the ratio 1:2, the whole thing. So, AF is to BF is 1:1. In the similar fashion, AE is to EC is also 1:1. Therefore, AH is to HD is also 1:1. So, totally how many parts are there? Here there are 3 parts, here there are 2 parts. So, take a value which is divisible by both 3 and 2. So, I am taking AD is equals to 6. AD is equals to, take it as 6 units. If AD is equals to 6 units, I am dividing AD in the ratio 2:1. Therefore, AG is 2 out of 3 into 6, which is 4. GD is equals to 2 units. In the same manner, AH is equals to 3 units. HD is equals to 3 units. If you take it, AH is 3, GD is equals to 2, remaining is 1. So, finally, we get a ratio AH is to HG is to GD. Is equals to 3:1:2. Here in this chapter, we have seen various kinds of centers of a triangle, and we have gone through the basics of median and how median divides a triangle into different triangles and what are their ratios we have seen. In the next class, we will see more about medians and its properties. Thank you.